Procel, a closer look. I've already given you a bit of background about me, so enough of that. And let's move on and have the next slide, please. Super. Okay, so here we have Procel, and these are the main ingredients of Procel: acai berry, apple stem cell, beetroot, grape stem cell, Nigella sativa, red raspberry, and pomegranate. So there's a lovely mixture of plants and plant extracts. Whilst we're talking about this, can I just say that it's most important that if you mention it contains stem cells, please emphasize the fact that they are plant stem cells, that apple stem cell, grape stem cell, and so on. You know, because there's a lot of misinformation out there about stem cells. We don't want people to get the wrong idea that these are human stem cells. They're not. They're plant stem cells. So there we have Procel, very, very carefully chosen mixture or combination of plant products. And if we go to the next slide, please, Herr Klickmeister. Great stuff. So these are what these various plant extracts give us. They give us a nice combination of phytoestrogens, of resveratrol, and also arginine. And we're going to go on to explore what the heck these are, mainly the phytoestrogens, but also we give a passing mention to the resveratrol and the arginine. Suffice it to say that all three of these are very good antioxidants, but also the phytoestrogens do a whole lot more than just simple antioxidation work. And we'll go on to have a look at how and why they do this and what benefits that we can get from the phytoestrogen. Okay, can we move on, please? Next slide. So I've got a bit of a black bar across my screen, which is wiping out half the title, but what this reads is the trouble with modern life. And the trouble with modern life, as it says here, is that it is stressful. And quite apart from the stress of, you know, mortgage and family life and computers not working, we've got oxidative stress, which until very recently we thought there was nothing pretty much we could do about. Just the basic fact of being alive with our cellular biochemistry going on generates what are called reactive oxidant species, and this causes oxidative stress to our bodies. Depending upon where we live, we're also putting up with a greater or lesser degree of pollution. If you live in a city centre, then yes, you will get a lot of nitrous oxides from vehicle exhausts and so on. If you live near an airport, again, you know, you will get nitric oxides plus noise pollution, all of which causes stress. But the point to note here is that oxidative stress usually leads on to inflammation and inflammatory stress. We can deal with gut stressors in another session. I'd be quite happy to do another session on Protect if the demand is there. But for the time being, just latch on to the idea that we live in stressful times, whether down to our inborn biochemistry or due to external pollution, we are subjected to quite a lot of oxidative stress. And in turn, this oxidative stress leads to, or can lead to, inflammation. Okay, are we all happy so far?
Yep.
Are we okay for speed and pace?
Fine, fine.
Yes.
I'm recording this, so if anybody wants to read it, it'll be fine. So, next slide.
Okay, that's great. That's great. Right, thanks. And next slide, please. So a few general points on inflammation, and if you just press, yeah, okay. So firstly, short-term inflammation is beneficial in protecting the body's integrity. And so if we get some short-term injury, then our body makes sure that the injured site is inflamed and hurts a lot, so that you don't move it, because movement is anathema to wound healing. If we get a short infection, particularly a bacterial infection at a site in the body, again, inflammatory processes come in and they destroy the bacteria which are causing the problems. So in the short term, and generally speaking, inflammation is beneficial because it helps to protect our body's integrity, it helps to keep things working, it helps to ensure that we survive another day. But if we go on to the next point here, chronic long-term inflammation is almost always detrimental to health. And the main difference between acute short-term and chronic long-term inflammation, apart from one short-term and the other's long-term, is, well, there's very little difference between them anyway. It's all inflammation. It's just that chronic long-term inflammation is in the wrong place at the wrong time for the wrong reasons. And hopefully we can intervene here by either having a great diet or using some great supplements, or, as I do, a combination of both. If we take the next slide. Okay, again, a few general points about inflammation. So if we could take the first point, please, Paul. Right. What inflammatory processes do is, first of all, they increase the blood supply to the site of inflammation, just like I said. And secondly, next point, we get an increased leakage from the small blood vessels called capillaries in the region of damage or infection. This is caused by the cells which line the blood vessels, the endothelial cells, retracting, so there's bigger gaps in between them. Third point, white blood cells, well, this is what leukocytes are. Leukocytes will then migrate from the blood vessels into the tissue spaces. This is a process called diapedesis. And point 4, the leukocytes then release a whole range of inflammatory mediators at the site of inflammation. So many, if not all, of the inflammatory mediators that we'll be talking about are actually produced from white blood cells. Remember, in the short term, they're good. In the long term, they're nowhere near so good. So increased blood supply, increased leakage of vessels, white blood cells leak out, and then the white blood cells cause all sorts of damage. And on the next slide, I thought you'd be interested to see what this looks like. This is actually a white blood cell. So the big gray thing with the elephant's trunk process coming out, that's a scanning electron micrograph of a white blood cell. And what you can see is that its surface, which is its membrane, is really highly folded and ruffled. What this does is it increases the surface area of the white blood cell's plasma membrane, as it's called. And this means that the white blood cell is really, really good at looking out for trouble. If you've ever taken apart an air filter from a car, you know that it's highly folded. And the idea behind that is to increase the surface area so that it can trap more dust and similar. It's exactly the same principle with the white blood cell. Anyway, the little green sausage in the foreground, that's a bacterium. It's an E. coli. And you can see that the white blood cell is stretched out. It's called a pseudopodium. It's just Latino Greek for false leg. So what it's doing is it's detected something strange in its environment, and it's sent out an exploratory process. And any minute now, that bacterium is going to wonder what hit it. And it's going to be destroyed pretty damn quickly, because the white blood cell is going to release a whole range of inflammatory mediators which are going to break down that bacterium and ensure that it can no longer do us any harm. But can you see how the white blood cells flattened itself? This is how they squeeze out of the blood vascular system. So it sort of draws itself in. You know how you can draw your stomach in to make you thinner, and then it squeezes through the gaps between the endothelial cells and gets into the tissue spaces. Pseudopodia come out, detect foreign material, and off goes the inflammatory process. So that's what it looks like. If we take the next slide. Yeah, this is another type of white blood cell. This is called a macrophage. Again, it's a Latin name. It literally means a big eater. And what this macrophage is doing is it's in a target-rich environment. The little yellow sausages, they are, again, bacteria. And you can see how the macrophage is shoving out loads and loads and loads of projections to deal with the bacterium. So, again, highly folded membrane, which rapidly or massively increases the surface area of the cell in order that it can detect as much foreign material as possible. So that's what it looks like. Okay, back into the words. Next slide, please. So a few common features of inflammatory processes. As previously said, it's a normal inflammatory response, but in the wrong location. And the next point. It often relates to inappropriate barrier function. In other words, the lining cells of blood vessels get a bit leaky. And the next point. This leads to inappropriate triggering of inflammatory processes and a lack of downregulation. We've got all sorts of checks and balances in our bodies to make sure that inflammation stays where it should, but every now and again things break down and we get chronic inflammation in the wrong place for the long length of time, and this can lead to tissue damage in the long term, as I think the last point makes. So yeah, tissue destruction with loss of function. So moving on to the next slide. A few more points about inflammatory processes. Again, this is quite technical. This is the reason why it's in a lighter blue color. But there's a whole load of technical terms here. You don't need to worry about them. They're just here for further information. So we get an overproduction of inflammatory cytokines. Again, a biological term, it just means a chemical that causes cells to move. What cells does it cause to move? White blood cells. It basically causes white blood cells to move. The main player here is TNF-alpha, and that stands for tumor necrosis factor alpha, and it's a major inflammatory modulator. We then get interleukins and interferons. We get overproductions of chemokines, basically monocyte chemotactic proteins, calling in the monocytes the cells we saw a couple of slides back, which cause a lot of trouble. And the next point, please. Overproduction of icosanoids. You may have heard of prostaglandins. Icosanoid is the general chemical name for the prostaglandin family. But the two major inflammatory processes or players here in the prostaglandin world, prostaglandin E2 and leukotriene B4. And this should be, overproduction of matrix metalloproteinases. These are the guys which cause all sorts of nasty inflammation in such stuff as rheumatoid arthritis. So a few common features of inflammatory processes. And believe it or not, our old friend Procel will have a good go at damping down all of this lot. And hopefully I'll be able to explain how and why this happens. Okay, so we've got a few more points here, if you would please, Paul. Right, many mediators, many of these chemicals that we've seen converge on something very important. This is NFKB. It looks like NFKB. It's pronounced nuclear factor Kappa beta. Now, nuclear factor Kappa beta and its partners in crime are very complicated system. Suffice it to say, all you need to know is that what nuclear factor kappa beta does is it upregulates and causes your DNA to start making more in the way of inflammatory mediators. Okay, so inflammatory enzymes and the products of inflammatory enzymes. Working against NFKB, sorry, nuclear factor kappa beta, is PPAR gamma, peroxisome proliferator activated receptor. I told you it was complex. And liver X receptors. So we've got two systems working here in a seesaw fashion. NF kappa beta tending to, yeah, get in there, inflammation, go. And then PPAR saying, no, just calm it all down, guys, calm it all down. I think that's all there is on this slide. Oh no, otherwise to say that tissue remodeling often results in the long term. So getting back into the major theme here, nutritional targets for intervention. How can our diet offset all this tendency towards inflammation? And the answer is, well, quite easily, really. The various inflammatory mediators we've seen are reactive oxygen species, either from pollution or just from being alive. Prostaglandins and leukotrienes, PGs and LTs. Chemokines, notably interleukin 8 and monocyte chemotactic protein 1. Various inflammatory cytokines, that's this lot. Note tumor necrosis alpha there. Tumor necrosis factor alpha, that's the big player. The next point, matrix metalloproteinases. And transcription. So nuclear factor kappa beta and tumor necrosis factor alpha, together with the reactive oxygen species and the prostaglandins, those are the major players here causing us problems. And how can we go on to deal with this? Well, I think I'm right in saying that Procel and Protect have got some reasonably good levels of antioxidant vitamins in them. I remember seeing this on the promotional videos. But the antioxidant vitamins, easy to remember, just say ACE, and you've got vitamins A, C, and E, and these are the major antioxidant vitamins. So as a general principle, oxidant stress promotes inflammation via nuclear factor kappa beta. And we just learned that that's a big pro-inflammatory, which therefore means that antioxidants must reverse this or go a long way towards reversing it. So prevention of what's called low-density lipoprotein oxidation and the formation of reactive oxygen species are common themes throughout nutrition. And taking stuff like Procel, yep, that will help us a great deal. Little word of warning here with respect to vitamin A. Dietary sources of vitamin A are generally speaking safe. Supplemental sources of vitamin A need to be treated with caution. So if we take the next point, please. Because vitamin A can be a pro-oxidant in smokers. And if you are either trying to get pregnant or you are pregnant, you really ought not to be taking supplemental vitamin A because it can cause damage to your unborn child. Again, those are a few points that are not widely known. So, as I said, I think that Procel and Protect contain vitamin C and vitamin A, and vitamin E. So they ought to be safe. I think there's a couple more points on this slide. No? No? Okay. Then let's move on to the phytoestrogens, which are a major component of Procel. And phytoestrogens, these are highly colored plant pigments. You find them in highly colored vegetables. They're also known as isoflavonoids or isoflavones. Again, this is more the sort of chemical scientific term for them, but you know, you will hear these terms bandied about quite widely. They do have a common chemical structure. The common chemical structure is polyphenolic, if you want to know that, but it's not really that important. And they're usually processed by the bacteria in your guts before they are absorbed by the body. And the typical absorption fraction is around about 1%. Now, of the phytoestrogens that you take on board, that you eat, only about 1% will get into your blood vascular system, but boy, it's a powerful 1%. So phytoestrogen, again, it's one of these compound words. Phyto means plant. Estrogen, well, we all know that estrogen means female hormone. Perhaps what's not quite so widely known is that the term estrogen is a generic term, a blanket term, meaning all of the female sex steroids. So how do phytoestrogens work? They will suppress inflammatory cytokines, the interleukins that we've seen. They'll have a direct antioxidant effect, so they will mop up reactive oxidant species. They will modulate inflammatory nitric oxide synthetase. So this is the enzyme which makes nitric oxide, which causes a vasodilation. Remember, we said back at the beginning that as part of inflammation, you get an increased blood flow to the affected area. And this is how the increased blood flow is brought about, by nitric oxide synthetase. But this inflammatory process is damped down by phytoestrogens. And nuclear factor kappa beta is inhibited by phytoestrogens, which all helps. And we get what's called partial agonism of steroid receptors. This is quite a nice concept, actually, that steroid hormones, in fact, all hormones, work by interacting with a specific receptor. It's a bit like getting pieces of a jigsaw puzzle to fit together, in that the steroid hormone is the last bit of the jigsaw puzzle. It binds into the receptor. The receptor says, hey, I'm stimulated, and off we go. And when a hormone binds to a receptor, that is called agonism. And as you probably guessed, agonism is the opposite of antagonism. Okay, so we can agonize receptors, and we can also antagonize receptors. Now, the way that phytoestrogens work is that they will bind to the corresponding steroid receptors. And they'll bind not only to the estrogen receptors, but they'll also bind to testosterone receptors as well. And what we're beginning to appreciate is that an awful lot of health problems in our modern world is caused by an overstimulation of these sex steroid receptors, an overproduction of hormones. Environmentalists will say, well, it's thanks to the contraceptive pill that, you know, high levels of estrogens are excreted in the urine, find their way through sewage treatment plants, and eventually get recycled into drinking water. I'm not here to say whether that's right or wrong. I'm a little bit skeptical about that. But be that as it may, certainly several diseases, for example, breast cancer, prostate cancer, no two ways about it. You know, they are steroid dependent tumors. And there is evidence to suggest that what we can do is we can reduce that tendency by agonizing partially the steroid receptors in those tissues. So a phytoestrogen, it binds to a steroid receptor, but it doesn't have the full biological activity of the naturally produced hormone. Okay, so these plant products, they will bind to estrogen and testosterone receptors, but they've only got about 1/2000th of the activity of the naturally produced steroid hormone, either estrogen or testosterone. And in doing that way, what they're doing is they are reducing the effect of the body's own steroid hormones. Okay, can we take the next slide, please, Paul? So, suppression of cytokines. Okay, Sippy's probably heard of COX-1 and COX-2 enzymes. These are inflammatory enzymes. And if you've heard of NSAIDs, non-steroidal anti-inflammatory drugs, what NSAIDs do is they inhibit COX-1 and COX-2 enzymes. But many flavonoids will inhibit quite powerfully COX-1 and COX-2 inflammatory enzymes. So that's one big point for phytoestrogens and Procel. I should have mentioned earlier that the major players of the phytoestrogen family, there's genistein, there's coumestrol, there's biokainin A, and there's something called diadesin. But genistein, which is one of the major players, it inhibits the output of these inflammatory cytokines from monocytes, so it reduces the inflammatory effect of monocytes. And the next point, yeah, just olive oil, in fact, will decrease the output of the inflammatory leukotrienes, leukotriene B4 and thromboxane B2. So you've probably all heard of the Mediterranean diet, which has got a lot of olive oil in it. And a Mediterranean diet is nicely anti-inflammatory. And a lot of that anti-inflammatory comes from the olive oil, but also a lot of it comes from the highly colored vegetables, which form a part of the Mediterranean diet. And as we already know, highly colored vegetables are very, very rich in phytoestrogens. So olive oil will increase the serum total antioxidant capacity. Okay, and if we move on, the actions of these antioxidants then. Right, this is a bit of scientific chemistry, really. It's just really reiterating the point I previously made, that the phytoestrogens themselves, because they're polyphenolic, they are very good antioxidants in their own right. And the next bit, again, a little bit more science. So if you know what a free radical is, then this will tell you how the free radicals are going to be quenched. So they're very, very good at eliminating reactive oxygen species. So very, very good at reducing oxidant stress. So nitric oxide synthetase, this can be modulated. Inducible nitric oxide synthetase is most affected. By inducible, what I mean is that the level of this enzyme can be varied, either upregulated or downregulated. This is the enzyme, as previously mentioned, that usually responds to bring about inflammatory vasodilation. So phytoestrogens will downregulate our nitric oxide synthetase. There we go. So flavonoids or phytoestrogens will inhibit the induction of inducible nitric oxide synthetase for induction reactivation. So flavonoids do not directly inhibit INOS, but what they'll do is they'll upregulate, or sorry, they will downregulate the amount of this enzyme that's present in the tissues, again by controlling the amount that's being transcribed of DNA. And wherever you see the word transcription in biology, you know that DNA and RNA are in there somewhere. So we take the first point. Yeah, phytoestrogens or flavonoids will inhibit the expression from DNA of inflammatory enzymes and proteins. So again, a very potent, a very, very powerful mechanism. They will suppress the activity of nuclear factor kappa beta, which is one of the major players in upregulating DNA and telling DNA, please make these inflammatory modulators. And it'll also suppress the activity of activator protein 1, which again is another key player in the activation of DNA to make inflammatory proteins. And the effect is mediated by a variety of enzymes called kinases. Don't worry too much about what a kinase is for the moment. Again, we can always come back and revisit this in a later session. But the important thing here is the first point: flavonoids will inhibit the expression from DNA of inflammatory enzymes and proteins. And if anyone asks you how, they just say, well, suppress the activity of NF-κB. So, partial agonism of steroid receptors. The flavonoids will strongly occupy the estrogen and testosterone receptors, but their biological activity is only about 1/2000th of the naturally secreted steroids. So what they'll do is they'll prevent your tissues from being overstimulated by these hormones, which, as we now know, can cause trouble. And this is of huge potential benefit in the control of steroid-dependent tumors. Two important words there are potential and control. They're not a cure. Okay. In the long term, if you're on a diet that either contains lots and lots of highly colored vegetables, or you take a supplement similar to Procel, then you can expect to receive long-term benefit in this way. If you've already got a steroid-dependent tumor, then it's not going to cure it for you. It may help to control it, but it's not going to cure it. Again, that's an important point to make. And partial agonism, an analogy. And this is where you realize that I've taken some of these slides from my old lecture presentation series at the college. This is a censored picture of someone who used to be a highly prominent politician in the United Kingdom. And you can probably see he's quite a big chap. He's a big bloke. He was knocking on for 200 kilos in weight. And he had a very messy divorce from his wife. And Paul and I, we're both married men. We both know what you girls are like. We both know that once you get together in exclusive female company and over a bottle of something nice, then your conversation is enough to make the average rugby club blush. And so this chap's ex-wife was with a few of her girlfriends, and they got through a couple of bottles of wine, and the inevitable question came, come on, Sarah, spill the beans. What's he like in bed? And she took a long swig of wine, and she thought for a bit, and she said, well, put it this way. It's like having a wardrobe fall on top of you, but with the key sticking out of the door. And in so doing, she described partial agonism exactly. Absolutely. The receptor was occupied. It wasn't being stimulated strongly, if at all. And to actually remove that blockage from the receptor would have taken an awful lot of effort. So there we go. That's an analogy of partial agonism. Again, it's quite a useful phrase to know. And yes, if you can imagine, that's the kind of thing that was going on. Or rather, yes, in her mind, that was what was happening. And on that note, we'll leave it there. Procel's ingredients are a very good source of phytoestrogens, a very good source of resveratrol, a good source of arginine, and now you know how they work. via antioxidant functions, and via partial agonism. And thank you very much for listening.